Imagine this. You're playing an online game. You press shoot and your enemy is already gone before the bullet leaves your gun. Or you're streaming Netflix and instead of smooth HD, it keeps buffering at the worst moments. The culprit isn't just slow internet. It's three key factors: the latency, bandwidth, and throughput. Together, they define the real speed limits of the internet. Hi guys, I'm DHT Ghost and welcome back to the DHT Ethical Hacking Mega Course. Episode 13, Latency, Bandwidth, Throughput, the Internet's Speed Limits. In this lesson, you'll learn what these terms really mean, how they work together, and why they're at the heart of network performance. Vorbarser latency. The waiting time latency is the delay between sending a request and getting a response. Measured in milliseconds, and it's the round-trip time. Think of latency like shouting across a canyon. The echo takes time to come back no matter how loud you shout. Low latency, 20-50 meters, feels instant, perfect for gaming or video calls. High latency, 200-300 millimeters. You start noticing delays. In gaming, that's lag. Extreme latency, 600 meters plus. Feels unusable. Commands arrive too late. Latency depends on wire distance, network congestion, and routing efficiency. Even with fast bandwidth, high latency ruins real-time communication. Bandwidth. The highway width bandwidth is the maximum capacity of your connection, usually measured in megabits per second, Mbps, or gigabits per second, Gbps. Imagine a highway. A 4-lane highway, high bandwidth, can carry more cars at once. 5-lane road, Mossy's low bandwidth, clogs quickly. Bandwidth doesn't guarantee speed, it only defines the size of the pipe. So if you have a 100 Mbps connection, in theory you can download 100 million bits per second. But reality is more complex. Throughput, the actual flow. Throughput is the real amount of data delivered successfully, measured over time. If bandwidth is the highway, throughput is the high number of cars that actually make it to their destination. Traffic jams, accidents, and detours reduce throughput. Similarly, network congestion, interference, and packet loss reduce throughput below the maximum bandwidth. For example, you pay for 100 Mbps bandwidth. Latency to a US server is 150 ms. Congestion means you only get 60 Mbps throughput. That's why speed tests often show lower results than your plan. How they work together: and high bandwidth plus low latency, best experience. Fast downloads, smooth gaming, crisp calls. High bandwidth plus high latency, Azure frustration. YouTube buffers fast but games lag. Low bandwidth plus low latency are smooth but limited. Great for gaming, bad for big file transfers. Low bandwidth, high latency, worst case, everything feels broken. The internet's speed limit isn't just about megabits, it's about the balance between these three. For real-life examples, the video call needs low latency, 100 millimeters. Bandwidth doesn't need to be huge, maybe 2 Mbps, but latency kills quality. Streaming Netflix needs consistent throughput. Latency doesn't matter much, buffering hides it. But online gaming needs both low latency and decent throughput. Bandwidth isn't huge, but latency is life or death. Downloading a movie. Bandwidth is king, latency barely matters. Different use cases different priorities. Hackers' perspective. Understanding these metrics is gold for both attackers and defenders. But DDoS attacks flood bandwidth to destroy throughput. Low latency exploits force delays by rerouting or intercepting traffic. Throughput manipulation. Injecting junk packets lowers real throughput for victims. Knowing the speed limits helps hackers disrupt and defenders detect unusual patterns. Charms how to measure measures latency. Speedtest.net shows bandwidth versus throughput. Shows where delays happen across hops. As an ethical hacker, tools like Wireshark let you analyze packet delays, retransmissions, and real throughput in detail. First here, the big picture: latency is delay, bandwidth is capacity, and throughput is reality. Together, they explain why fast internet sometimes feels slow, and why gaming, streaming, and downloading behave so differently. Mastering these three concepts is mastering the physics of the internet itself, the speed limits of our digital world. This was episode number 13 of the DHT Ethical Hacking Mega Course. I'm DHT Ghost. If this gave you clarity, smash like, subscribe, and comment. Is latency or bandwidth more painful for you? In the next episode, we'll dive into IP addressing, the digital identity of every device. Keep learning, keep hacking ethically, and I'll see you in the next one.